All right, ladies and gentlemen, if you could please make sure you have a whiteboard, a dry erase marker. Go ahead and get a Kleenex if you need to. Also, you may want to have out your study buddy so that you can, write down any notes. We're going to cover a few different things today. So, hello, Delaney. That's fine. That's fine.
You got an award?
You didn't get an award? Wow. All right, if we could hurry up, please. Whiteboard, marker. We'll do it tomorrow. Okay, we'll finish it up tomorrow.
Sorry for being late. I recently
ELP stuff.
Yeah,
Yep. Yep. Yeah, go ahead. All right, ladies and gentlemen, just for those of you who came in, if you could please get a whiteboard, dry erase marker, Kleenex. And if you want to have out your study buddy as well, we're going to be doing a little mixed review today where it's going to be just a little bit of instruction, some practice on your whiteboards, that sort of thing. So it may be something that you're like, hey, I want to make sure to write that down on my study buddy. Remember, ladies and gentlemen, your final will be on Thursday during 4th and 5th periods. Your 5th period teacher does know that you will not be in 5th period on Thursday. So please, make sure to get to 4th period. Make sure to get to class as quickly as possible so we can get started as quickly as possible. Katerina, can you get the door, please? Just shut it most ways so we can get back in. Thank you. All right. So today we're going to look at a couple concepts that I feel like are important for us to cover. Growth and decay, functions, and then we're going to look a little bit at quadratic formula, and axis of symmetry. Tomorrow we're going to look at a little bit about operations involving radicals. But again, if between now and then, if there's any questions you guys have about certain things, don't hesitate to ask. Okay. So if you have a textbook, page 432. Growth and decay functions. And I have these written up here on the board for growth and decay. They're both pretty much identical except for one operation sign. So for growth function, y is equal to a times the quantity 1 plus r, and that's the rate in decimal form raised to the t power. In other words, the time, the elapsed time. The decay function, the only difference is instead of adding the rate, we're subtracting the rate from 1. So a helpful tip, and again, I'm not saying stuff that's going to be on the test, I'm just saying for the future. If you look at a function and you're asked, hey, is this a growth function or a decay function? All you need to look at is looking at this point right here. If whatever's being raised to the power is greater than 1, it's going to be a growth function. If whatever is being raised to the power is less than 1, it's going to be a decay function. It will be a decay function. So either or. Okay? Makes sense to everybody. And that's just one helpful hint. So we're going to do one. And you also, I failed to mention this, you need to get a calculator. You can grab a calculator as well. So, let's talk about college tuition. Okay? Now let's say a college tuition has been rising 5% each year. So our R is going to be 5%. Now, since it's rising, this is going to be a growth function. Okay? Say the initial tuition is $10,850. That's going to be our A value. And let's look at T as 15 years. So I want you to calculate the tuition, the initial tuition is $10,850, and it rises at a rate of 5% a year. After 15 years, what will the rate be? Or excuse me, not what will the rate be, what will the tuition be? So calculate that, pull up your answer. Now remember, ladies and gentlemen, since we are dealing with money, you want to round to the nearest cent. Make sure you round it to the nearest cent. Also, make sure you're labeling your answer. We're dealing with money here, so it should have something in front of it. Correct. Yes. If you get stuck, you need any help, don't hesitate to let me know. Yes. 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 Remember, round to the nearest cent, not the nearest 10 cents. Yes. 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 Oh, that's what people are just like, is this? Yes. Yes. No. Yes. Okay. So you're going to take 1.05 and raise it to the 15th power and multiply. Ah, that would make a difference there, yeah. Yes. Yes. Yes, Ty. Yes. Yeah, be very careful when you're doing your calculations. Yes, and Jordan, I like that. You look at it like, this isn't right, but I'm not sure what I did. Now times 10,850.
Algebra.
Okay, so you should have gotten, a lot of people got, now it's $22,556.37. Again, I noticed some people rounded to 0.4 or rounded to the nearest dollar. Remember, since we're trying to be as specific as possible, round to the nearest cent. So ask yourself, is this to the nearest cent? So when you round to 0.4, it doesn't say to round to round to the nearest tenth of a cent or nearest dollar, round to the nearest cent. Okay? All right, for compound interest. Now, compound interest is a little bit different than growth and decay, because with compound interest, what is happening is that the interest that is being earned is basically added onto the principal at regular intervals. Okay? This is over a yearly. This is where interest is compounded. Now, I will tell you guys, and you don't have to do this on your study buddy. If you've already done it, that's fine. But on your study buddy, you don't need to put the list of what every compounding is. If I'm asking you to compound something, I will tell you the amount of intervals that it is. Okay? So for example, if something I say is compounded quarterly, I will put in parentheses 4 times, or something along those lines. So you don't have to have that whole list, just because. So the difference here is that n. Basically, it's almost the exact same thing, but here we're dividing the rate by the number of times interest is compounded per year. And then for our power, we're taking the time, and the time in this case is in years. In a growth and decay function, time can be in seconds, time can be in weeks, time can be anything. But in a compound interest equation, time is in years. So if it says 3.5 years, you're going to put 3.5. Or 4 1/3 years, you put 4.333, something like that.
You can have these up on the board when you're taking a test.
Well, Preston, I'm just reminded that you have this 8.5 by 11 piece of paper. That you can write anything you want on it. Perhaps you might want to write that on there as well. There is going to be some stuff written on the boards, but I wouldn't bet, because I have other stuff I have to do, so it's gonna get a raise at some point.
Yeah.
So that's why I give you guys the study method. Okay. All right, so let's do one of these. So let's say your principal amount. Now the principal amount is the initial amount. Let's say your principal amount is $500. Okay. And your rate of interest is 4.5%. We're looking over 25 years. And I'll be nice. Let's say the compounding is annually. So that's just going to be one time per year. Okay, so you're investing $500 at 4.5% for a time of 25 years, compounded annually. This one we need to figure out. And remember, near cent. Yes. Yes.